Assalamualaikum and good evening to our lecturer, Professor Madya, TL Dr. Felix Langmiller, and my fellow friend. I introduce myself. My name is Muhammad Azuwan bin ANUAR, and my teammate is Muhammad SHARUL bin YUSOFF and Muhammad AFNAN HAMIMI bin Muhammad AZAM. So this is our project Geosynthetic design. So the article that our group choose is Geosynthetic and Hydraulic at Coastal Engineering, which is in this article also talk about the filter, recruitment and self-filler structure. This article are made by A. Bezugen, which is at University Ghent in Belgium, and also the consultant from the coastal sector is K.W. Pilach. So for the introduction, this article contains two geotextile applications in coastal area. So the geotextile used in a filler under revetment and the sand filler structure. And also this article want to replace granular filter with geotextile. In this article, I state the filter criteria, permeability of the geotextile perpendicular to the plan, design of block revetment and geometers, sand filler geosynthetic tube and containers, and stability sand filler geosynthetic tube and container under wave attack. So for the filter criteria, if you can see at the picture, filter layer are at the below of the revetment. We put the filter in there. The actual function filter is to prevent the fine material wash out. If you can see at the above the filter materials most at vanish by using one granular layer, and the below one filter materials essential storm touch barrier using 3 granular layers. So this is depend on the type of project and also the objective to choose the best criteria. For the subsoil, is applied when you find if the filter cannot pass through the pore of the larger material. And the third one, the opening size must be enough of the filter has to be limited to prevent subsoil transport and prevent blocking in geotextile. So in this criteria for the filter, we need to choose carefully because we don't want to make the granular material to wash out. In revetment sector, a layer of granular material that acts as a filter can have more function than the filter function. The weight of the granular layer are using to instability of the soil to prevent. So the more we using the granular material, the more weight that we can stabilize the slope. If we using more geotextile and the layer become thin and the slope become unstable, so it will the structure failure. The second one is about the permeability of the geotextile perpendicular to the plan. So you can see at the graph, the permittivity of the geotextile with sand is 4.5 to 35 times lower than the permeability measured in the index tag without soil. So the conclusion that we get, for woven to be used in a filter, the opening must be more than 10% of the total area. For non-woven geotextile, the porosity must larger than 55%. So if you can see at the graph at the bottom, the permittivity effect and influence the permeability of the geotextile, which is the higher the permittivity, the lower the permeability, and also the lower the ratio, the higher the porosity. So this is all for me. I will pass to my friend for the next chapter. Thank you.
Assalamualaikum warahmatullahi and salam sejahtera. Doktor, my name is Muhammad Sharul bin Yusoff, TF 170015. I want to present about my topic, my research journal about design of block reinforcement and geometries. In reinforcement structure, geotextile are mostly used to protect the subsoil from washing away by the hydraulic load such as wave and current. Second, the permeability of the mattress is one of the factors that determine its stability. The clogging of the geotextile can cause a decrease in the permeability. Duration geometers is ultraviolet UV. Strength degradation of geosynthetic is mean that for structure with long lifespan, the stability of the material should be controlled for this situation and avoid any possible of damage by corrosion. This is an example for calculation and design the mattress, concrete mattress. Can result we got the stability of the concrete. Then that continues the sand filler, geosynthetic tube and container. Okay, the first one, sand filler geotextile tube and container. There also exist slurry filler geotextile tube and container. Comparable and to make a large structure that is stable in current and wave attack. Geosynthetic tube are mostly used for coast and shore protection. Structure was made to increase the wave height and surfing and also to provide some shelter for the same surfer. Also different in degree of filing and can determine shape, the height of the tube or container. Okay, the example secondary dam structure with geosynthetic cube as a core. Okay, you can see. Okay, that's all. Thank you.
Hi, my name is Muhammad HAMIMI bin Muhammad AZAM. For the next topic, I will talk about the stability of central geosynthetic tube and container under wave attack. For the introduction, evaluating the failure mechanism of central tube and container, it appears that the construction period is a critical period. The second one is this article focusing on the failure mechanism of important after construction, scour and stability again with attack. For the first subtopic is a scour. You can see geotextile tube often used for at beach for coast protection. According to Das Neves, tests show that the scour depth of a geotextile structure is comparable to the scour depth of rock and gravel structure. For the second subtopic is a stability under wave attack. The stability of under wave attack of central geotextile tube and central geotextile container is recently tested in the Netherlands by Van Stick et al. 2011. Geotextile container with a relative low degree of filling, there appear to be also a different failure mechanism possible. There are two failure mechanisms, which is geosynthetic tube and central geosynthetic container. From the up left, you can see on this figure, we show the geotube on the beach. For the geosynthetic tube, a significant deformation of the tube did not take place except for the tube, which was filled for 55%. Tube with higher degree of filling deformed as a function of the degree of fill. Failure of the two wall stack occurred due to a seaward sliding mechanism of the tube on top and the tube which was placed on the seaward side of the stack. The chart about the filling percentage and settlement of the tube. The next one is central geosynthetic container. As we can see, a degree of filling of 60% or very low tension fall geosynthetic will allow the sand migrate and start what is called caterpillar failure mechanism. The whole geosynthetic container moves due to the migrating sand as a caterpillar from a bulldozer, resulting in larger and larger deformation. The consequence of this caterpillar mechanism is that central geosynthetic container will deform at a significant wave height higher than 0.8 meter, according to the measurement in the film. Minimum of 4 meter water depth is necessary to dam the container. As we can see, this example of the central container that we using on the beach. For the conclusion, we conclude that the filter rules are derived for a stable soil layer. They need to be stricter when soil can move around underneath a geotextile filter, as is the case where there is a wave attack at a sand-filled geosynthetic container. In a coastal engineering application, the subsoil in a filter should fulfill the Kenny and Lau criteria to be sure that there is no development or impermeable layer in the subsoil. The stability of the sand-filled geosynthetic tube and the wave attack can be calculated using the formula given in this paper or more in general by the formula presented by That's all from us. Thank you.